Okay, so this one we are going to draw a scatter plot of the waist measurements of 9 people and their weight. So what do we got? So the first thing you got to do is you have to put this on a scatter plot. We've already got the grid lid, the graph there. So start plotting this on the scatter plot. I'll do it as well. Should be almost done this, guys. Suck it up, princess. $84.68, $82.71. $90.79. All right. What's that? The weight and the waist are on different axes. It depends. Yeah, you can go to the weight and go up and then go across, but I would get in the habit, Jacinta, I would get in the habit of doing the x-axis first. Yeah, because that is the convention, and it's the way coordinates are written. So if I wrote it as coordinates instead of writing that, if I wrote down 102, Jacinta, if I wrote that down instead of having that table, you have to know that you go 102 across before you go up. Whereas if you tried to go up first, it doesn't work. Coordinates, ordered pairs always go horizontal, then vertical. You done this, Lever? Good. Now draw a line of best fit. Now, when you draw the line of best fit here, can I recommend that you go all the way across to the y-axis. So there's my line of best fit. I'll just zoom in on it for a sec so you can see what I'm doing. That's my line of best fit. Okay? So from that, we're now going to write the equation. And this is where I would recommend that you actually pay attention. Because if you can't do this, this isn't just for the health topic. This is for algebra and linear relationships. So this is the sort of questions you get asked to do in graphing linear relationships. Okay. So that's our line of best fit. Excellent. Now, what do? We want to get the equation. What's the equation going to look like? Excellent. That's the gradient intercept form of a linear equation. That's perfect. It's the one to use. So what do you reckon is going to be the easiest thing to work out to start off with? Or what are the two things we have to work out to get the equation? There's two things. Gradient, which is m, And what's the other one? B. Excellent. Now the gradient, we just remember, is rise over run. So we'll just write that one. Rise. Okay. I don't even drink spirits. Okay. Rise over run. So B, what's our y-intercept going to be? Now yours might be slightly different, but I've done mine the same as the textbook. What's the y-intercept? Yes. Now give me a number. No, it's not. I've just drawn a line of best fit that goes through the y-axis. You should be able to tell me the y-intercept. I went to 20 because my line of best fit went through there, and I just continued my line of best fit on. It'll probably be 20 or like 21 or maybe 19, or what'd yours come out as? 10? Okay. The whole thing is, now, this is where it becomes very subjective. Because you've plotted it, you might not have done your plots accurately, so they mark you down for that, but your line of best fit may be perfect for the data you've plotted, and so you'd get the mark for that. And then if you do everything else based on your line of best fit, then that's fine. So if yours looks like it's at 10, then do yours as 10. Okay? This is where marking your stuff is fun, because I get to do it 12 times or 18 times, depending on who does it differently. And if you've done everything else correctly, then you've done everything else correctly. So, all right. So my y-intercept is 20. Kelsey's might be 10. Yours might be 18, 15, 21, whatever. Okay. All right, next bit. Rise over run. We've got to find out the gradient. So just to show you, we've now done part of this. We've now got y. Oh, hello. You're very thin. We've now got y equals something x plus 20. So we've almost got our equation. We just need our m now. We just need our gradient. So how are we going to work out our gradient? I don't know. I haven't worked it out. How'd you work it out? Now, don't forget, you do not do it necessarily from your points. You can, and it's probably easier to do it from your points. So do we go through one of these? Like, that goes through that one pretty much, doesn't it? Would you agree? Kirby, do you agree? So if it goes through one of them, you can use that. You could use this point, and you could use that next one. So I'm going to use this first one, because that's 0, 20. Yeah? Yours would be 0, 10. Okay? It's going to be 0 something. Okay? And my other one is 180. Okay? So my 2 points that I'm going to use are 0, 20, Levi. And my other point that I'm going to use is 180. Does that make sense? Nope. What does yours go through? What does your line go through? Pick a point. If it goes through one of your particular data points, work out which one it is, use it. Pick one. Yeah, it looks like, what's mine going to be? Mine's going to be 60 over 100. Yes, it is. Oh, no, it was 102. But mine's closer to 100. You could use 102. Okay. So we've done that. So what's my rise? I've gone 80 from 20, and I've gone 100 from 0. So I'm now working out my rise over my run. I've gone from 20 up to 80, and I've gone from 0 over that. Yes and no. If you use this one first, you're going to end up with a negative number, but you'll end up with a negative as long as you use both of those first. Like if you did 20 minus 80 and 0 minus 100, you'll end up with minus 60 over minus 100, and those two negatives cancel out, and you end up with 60 over 100. So, and that's exactly what I'm going to end up with. Yeah. I'll pause. All right, so if you simplify that fraction down, we've got 60 over 100. You're going to end up with 3/5. Okay. So 60 over 100 simplifies down to 6 over 10, simplifies down to 3 over 5. And I don't care if you chuck 60 over 100 into your calculator equals, because it will give you 3 over 5. Sorry, hang on guys, I can't hear. 10 over 17, is that what it's simplified down to? Then that's fine, that's yours. Yeah, if 10 over 17 is yours, then you end up with 10 over 17x plus 20. Yeah, whereas mine will be 3 over 5. And that's my equation. Okay? Kels, what did you work out for your gradient for M? Because you've got 0, 10 up to, was it 99, 70? 90, 77. Okay, so your rise has been 67 and your run has been 90. So you'll have 67 over 90, which probably won't simplify because 67 is a prime number, I'm pretty sure. So you will end up with that would be your one. Does that make sense? You calculated your gradient by working out how far it had gone up, its rise, over how far it had gone across, its run. Okay, and it had gone from 10 to 77, so it's gone 67 meters or 67 whatevers, and it's gone from 0 to 90. Cool? And you already had your y-intercept there.